Today we're doing a lab that will illustrate the properties of acids and bases. First of all, we're going to get a few squirts of hydrochloric acid, which is a clear liquid. This is medium concentrated hydrochloric acid to make sure it's concentrated enough to react. Then we are going to place a piece of magnesium metal. This is magnesium. Here's a whole roll of magnesium, and this metal is fairly reactive. So it will react much more quickly than iron would with hydrochloric acid. So place the magnesium into the hydrochloric acid. See the bubbles? Now, those bubbles are hydrogen gas. To prove it, hydrogen gas is flammable. So I'm going to light a popsicle stick, and then we're going to see if this gas will burn. If it does, it'll make a cool sound. You hear that? The test tube barked. No, it didn't actually bark, but that's what it's called. That's the sound that it makes when the hydrogen gas catches fire. So we do know that that was flammable hydrogen gas that was produced. When a metal reacts with an acid, it produces hydrogen gas. Fill that into your first line of your lab paper. Acids don't just react with metals, they also react with carbonates. So now I have a little more hydrochloric acid, and I'm going to add some sodium hydrogen carbonate, which is baking soda, to that. If it makes carbon dioxide bubbles, the carbon dioxide will put out a candle flame. So I'm going to pour the gas, not the liquid, onto the candle, and if it is carbon dioxide, it will put the candle out. Okay, that wasn't fast enough. So now I'm trying a graduated cylinder so I can have a little more acid in there. There we go. So carbon dioxide is not flammable. In fact, it will actually put out a fire. Some fire extinguishers actually use carbon dioxide to put out fires. Next, we're going to look at what happens when an acid and a base neutralize each other to produce a salt and water. We are using hydrochloric acid and sodium hydroxide, so this reaction actually will produce table salt and water. So I have some clear hydrochloric acid in here, and I'm going to add a drop of phenolphthalein. Phenolphthalein is clear in an acid and hot pink in a base. It's an acid-base indicator. So you see, this is clear, proving that we have an acid. Now we're going to add a base to this acid. And as it gets added, you can see a little bit of that hot pink. But once you add too much base, it goes very bright pink. Now let's go back and add some acid. When we add more acid than we have base, it's clear again. Then when we go back and add more base than we have acid, it's back to hot pink. Pretty cool, huh? Well, close. That one didn't quite make it. Have to add a little more. So if you can perfectly neutralize the acid and base, it will be a light pink rather than a hot pink, but that's fairly difficult to do. Ah, went right past. Yeah, so that's somewhat of a light pink. And if we add more, then definitely a dark pink. So phenolphthalein is clear in an acid, hot pink in a base, and light pink in a neutral solution. You would not want to try tasting this to see if you have any salt produced. First of all, if you had too much acid or too much base, you could get burned. But this phenolphthalein used to be the main ingredient in Ex-Lax. Yes, a laxative that makes you poop. So that's why you don't want to drink anything with phenolphthalein in it, because it will definitely sit you on the toilet. Finally, I don't have a demonstration for this, but a base will react with fats and oils to produce soap.